Namaskar, I am Anand and all of you are in the live session of Join for Education. In this class, I am going to solve the questions of exercise 7.1 of NCERT textbook. Let's see the questions of exercise 7.1. So, this is the first question on the instruction of the here. Find an antiderivative or original of the following functions by method of inspection. Let's see the question number one, sine 2x. Let's see the solution of this question. So we look for a function whose derivative is sine 2x. We look for a function whose derivative is sine 2x. So we recall that dc of cos 2x equal to minus 2 sine 2x. Therefore, here will be sine 2x equal to minus 1 by 2 dc of cos 2x. Hope that there is no problem to understand up to this step. So here next step will be sine 2x equal to dc of minus 1 by 2 into cos 2x. Therefore, antiderivative of sine 2x equal to minus 1 by 2 cos 2x. Hope that there is no problem to understand up to this step. Let's see the next question. So here question number 2 is cos 3x. Let's see the solution of this question. We look for a function whose derivative is cos 3x. So we recall that dc of sine 3x equal to 3 into cos 3x. Therefore, the next step here will be cos 3x equal to 1 by 3 dc of sine 3x equal to dc of 1 by 3 sine 3x. Therefore, we write down here antiderivative of cos 3x equal to 1 by 3 sine 3x. This is the answer. After there is no problem to understand the solution of question number 2. Let's see the next question. This is the question number 3. E to the power 2x. Let's see the solution. We look for a function whose derivative is e to the power cos 2x. For this, we recall that dc of e to the power 2x equal to 2 into e to the power 2x. After there is no problem to understand up to this step. So the here next step will be e to the power 2x. When these two move in the left hand side, then we get this step 1 by 2 derivative of e to the power 2x equal to, we write down here, derivative of 1 by 2 into e to the power 2x. Therefore, here will be antiderivative e to the power 2x equal to 1 by 2 into e to the power 2x. Hope that there is no problem to understand the solution of this question. Let's see the next question. This is the question number 4. So this is the question number 4. Ax plus b to the power 2. Ax plus b to the power 2. Let's see the solution. We look for a function whose derivative is ax plus b to the power 2. Recall that dc of ax plus b to the power 3 equal to 3 into ax plus b to the power 2 into a. Therefore, when 3a move in the left hand side, then we get in the right hand side 1 by 3a and ax plus b to the power 3 dy dx equal to, in the right hand side we have ax plus b to the power 2. Hope that there is no problem to understand up to this step. Therefore, antiderivative of ax plus b to the power 2 is 1 by 3a into ax plus b to the power 3. This is the answer. After there is no problem to understand the solution of this question. So here question number 5 is sin 2x minus 4 into e to the power 3x. Let's see the solution. We look for a function whose derivative is sin 2x minus 4 into e to the power 3x. Recall that dc of cos 2x minus 4 into 3 into e to the power 3x equal to minus 2 into sin 2x minus 4 into, so we take here 4 into 3 into e to the power 3x. Of that there is no problem to understand up to this step. To cancel out this 3, we write down here by 3. So we write down here by 3. Of that there is no problem to understand up to this step. For this one plus, so we write down here minus, so here will be minus minus plus. Of that there is no problem to understand up to this step. So the antiderivative, we take here 2, or we write down here by 2. So we write down here by 2. Of that there is no problem to understand up to this step. So here we cancel out 2, 2. Here we cancel out 3, 3. Then we get this one. Sin 2x minus 4 into e to the power 3x. Sin 2x minus 4 into e to the power 3x. Therefore, the antiderivative of uh, antiderivative of sin 2x minus 4 into e to the power 3x is this one. We write down here minus 1 by 2 into cos 2x minus 4 by 3 into e to the power 3x. So this is the answer. Observe there is no problem to understand the solution of this one. Let's see the next question, which is question number 6. So find the following integrals in exercise 6 to 20. Let's see first question or question number 6. Integral 4 into e to the power 3x plus 1 into dx. So there is no problem to understand this question. Let's see the solution. There is no problem to understand the solution of this one. Let's see the question number 7. Integrals x square whole square 1 minus x square into dx. So let's see the solution of this question. X square into dx minus x square cancelled out, then we write down here dx. So the derivative of this one according to x square plus 1 by 2 plus 1, and here will be x. So we write down here equal to x to the power 3 by 3 minus x, and we write down the arbitrary constant c. So here plus c. This is the answer. For the question number 6, we also write down the arbitrary constant c. So there is no problem to understand the solution of issue. So let's see the next question. This is the question number 8. Ax squared plus bx plus c into dx. Let's see the solution. Ax square into dx plus bx into dx plus c into dx. Hope that there is no problem to understand up to this step. So this is very easy question. The derivative of x squared into dx, sorry, integrals of ax squared into dx will be a into x to the power 3 by 3 plus c 1 and bx square by 2 plus c2 and plus cx plus c3. Therefore, we write down here ax cube by 3 plus bx square by 2 plus cx plus c1 plus c2 plus c3. And at last we write down here ax square plus 3 plus bx square, sorry, ax cube by 3 bx square by 2 plus cx plus c. So here we write down c1 plus c2 plus c3 equal to c. So this is the answer. Similarly, we can solve rest questions of this exercise. If you have problem, write into the comment box. I will arrange one more live class for the solution of the rest question. Attend next class for the solutions of rest questions of this exercise. Till then, thanks to all of you.